we should express this in partial fraction. How do you do that? First of all, we need to factorize the denominator. As you can see, this denominator is a polynomial. So the first thing we need to do, we need to use trial error to equate this to 0. That is to say, this equals to s raised to the power 3 minus 4s raised to the power 2 plus 3x. We need to equate it to 0 through trial error. We first of all say s be equal to 1. Let's try 1. Then we put 1 in place of this s. We put 1 here. We put 1 here. You agree with me? This is 1 minus, this is 4, this is 3. This will give us minus 3 plus 3, which is 0. It means if we put s to be equal to 1, we are going to get 0. It means, therefore, s minus 1 is one of the factors of this polynomial. Now, why did I say s minus 1? If you understand polynomial, the only way this can be 1 is to equate this equal to 0, which is s now minus 1 equal to 0, which is s equals to 1. So because we already say s equals to 1, is to bring s to the side to make it s minus 1 as one of the factors. Because if you have, for instance, for your quadratic equation, you agree with me, if you have something like this, s is equals to 1 or s is equals to 2. So when you have s as equals to 1, it means it's s minus 1 that was the factor. If you have s as equals to minus 2, for instance, minus 2, it means it was s plus 2 that was what? The factor. Therefore, because we now have one of the factors, we can do log division on this denominator. That is, we do like this. S minus 1 is the factor we are sure of now. We put these other ones inside this. Then we say this first one divide by x. The first one. You agree with me? S raised to the power 3 divided by x is s raised to the power 2. So we put the s raised to the power 2 here. Then we say this multiplied by this will give us s raised to the power 3. This multiplied by this will give us minus s raised to the power 2. Then we subtract. This minus this is 0. Minus 4x raised to the power 2 minus 4x raised to the power 2 minus this. That is minus this. It means this is plus s squared. This, therefore, is minus 3x raised to the power 2. So here is minus 3x raised to the power 2. Once we put this here, for this raised to the power 2, we must also bring this down, 3x. Then we continue. This shouldn't be here anyway. Minus 3x divided by x minus square divided by x. You agree with me? This is 1, this is x. That is minus 3x. We put minus 3x here. Okay? Then this multiplied by minus 3x will give us minus 3x squared. This multiplied by this will give us plus 3x. This will give us 0. This will give us 0. It means everything here now is 0. Therefore, we can express the factor as this s minus 1 and this s 2 3x. Okay? This is factor we can use to replace this denominator. And you agree with me, we are not still true. We are not true yet. We are not true because this still has what to factorize. So we say s squared minus 3x. You agree with me, what is common between this is x. If I bring s out, what is remaining now is x. Here is minus 3. Okay? So this is going to replace this guy. That is this guy. Meaning finally we're going to put this down, s minus 1, and this x, s minus 3. You can't write like this. You have to write this x first. Then we write s minus 1. Write this. Although you can leave it like this, but this is more professional. So this now is the factorization of this denominator. Okay? So therefore, we can boldly say this guy, which is 2s raised to the power 2 minus 5s plus 1 over this. That is x minus 1, x minus what? 3. So this is the one now. We're going to use our standard methods, any of the methods of partial fraction to work on. If you have been with us for a long time, you know we have treated partial fraction a lot. So now let's come here now to say it actually equals to A over the first one, B over this, C over this. Okay, now we know that if you find the LCM of this, you're going to get this. It means, therefore, we should multiply throughout by this. That is, now you agree with me, this and this will strike out to have 2s squared minus 5x plus 1 equals to this. So now, we're going to use this to multiply this. If we use this to multiply this first one, you agree with me, it will now remain, this and this will cancel, remains this other one, that is s minus 1, s minus 3. Therefore, this one, this and this will cancel, remains b x s minus 3. For this one, multiply by this and this will cancel, remains c, x and s minus 1. Okay? The first thing we need to do now is to start eliminating each of these to get the other one. You agree with me? I want to get a first. If I want to get a first, I want to eliminate b and c. The only way for me to eliminate b and c is to make s to be equal to 0. Because I know if I put 0 here, this will go and this will go. So therefore, we're going to say, let s be equal to 0. So 2, 0 here, raised to the power 2, 5, 0 plus 1 equals to a, 0 minus 1, 0 minus 3, b, 0. By putting 0 here now, this automatically is gone. If I put 0 here, it's gone. So no need to waste our time. So we agree that this will all go, okay? Therefore, this will also be 0, this will also be 0. It remains 1 equals to a minus 1 minus 3, okay? Which is a, this and this will give us plus 3, which you can also rewrite as 3a. Divide both sides by 3. You agree with me, therefore, a is equals to 1 over 3. We have a. How do we get b? To get b, all you have to do, this is b you are looking for now. This is the position of b. What do you see here that you also see here? I can see s minus 1, I see s minus 1. It means if I say, let s be equals to 1, this and this will go. So, I'm going to say, let s be equals to 1. So, I put 1 here, that is 2, 1 raised to the power 2 minus 5, 1 plus 1 equal to here. A, here, if I put 1 here, that is 1 minus 1. It will produce 0. It means no need to waste our time. This is already 0. If I put 1 here, it will be 1 minus 1, which is 0. Everything here will produce 0. No need to waste our time there. So let's only work on this. That is b, 1 minus 3, okay? Which is b minus 2. That is minus 2b. Come to this side, that is 2 minus 5 plus 1. This will produce minus 3 plus 1 equals to minus 2b. This will produce minus 2 equals to minus 2b. Divide both sides by minus 2. Okay, this and this will cancel. This here 1, this here 1. That is b, therefore, is equals to 1. Okay, so what is remaining now is c. Let's go for c. Let's go for C. Again, if we are going to look for C, this C, we ask ourselves, among these remaining ones, which one is common? This is S minus 3, S minus 3. Okay? Because S minus 3 are common here, we are going to equate S to be equals to 3. So that we can eliminate this and this to remain this. Okay? So therefore, we're going to say let S be equals to 3. So if I put 3 here and I have 3 raised to power 2 minus 5, 3 plus 1 equals 2. I will not waste my time with A and B because they are already going to produce 0. They are going to produce 0. So therefore, I concentrate here. C, 3 minus 1. Okay? So this will produce 2, 9, 15 plus 1 equals to 3, 2, 6. This is 18 minus 15 plus 1. This will produce 3 plus 1 equal to C, 6. This will produce 4 as equals to 6C. We divide both sides by 6, which is this. Here is 3, here is 2. 2 over 3. So C therefore is 2 over 3. Okay? So now we have A, we have B, we have C. We go back to our first expression. This was the first expression. We're just looking for A, B, and C. The reason for all you saw, okay? So we're going to say now this is actually equal to, what is our A? Our A is 1 over 3. 1 over 3, okay? So we come here now to say, in place of A, we put 1 over 3 x. It's actually 1 over 3 x, which you can write as 1 over 3x. Okay? What about B? B is just 1. Okay? So simply do plus 1 over s minus 1 because B is just 1. Okay? Then for C, what is C? C is what? 2 over 3. 2 over 3. So we come here to say, in place of C here, we put 2 over 3. Then we put these remaining ones, s minus 3. So this is the final answer. I don't know if you can see clearly. Okay? Hope this is understood. Thank you for viewing.